start. Hello everyone. Thanks for coming. Um, so yeah, we are at week 7. I have quick announcements. So I mean, you can first scan the attendance form if you need to, and board interest form is there. It's still open. We'll reach out probably next week for interviews and everything. Um, okay, done. Like, yeah, anyways. So, yeah, just a quick announcement. I mean, if you are on Discord, you probably have seen that we are currently number 1 in USA for WorldCon competition. Um, it's almost guaranteed that we won't be pushed out of 100. So teams who are in top 3 will receive prizes. Pretty sure most of the people are already silver level. But I have seen other like people who have done very well receive consultant offers already. Whoever reaches gold level receives that offer. So congrats on that. And like kudos to everyone who is like, participating enthusiastically. So it's still like 3 more days till the competition goes. Um, I have seen the recent emails. If you are registered, you'll get like example alphas probably every week. And those work very well. Like if you are just aiming for passing like one alpha on that portal, just try that. There is also a hint given. So I believe the recent one was on something where you can just edit the date. It currently is 252, and then if you do a quarter one, which is like 63, you'll pass all the test cases. So one line of code, 14% of grade, pretty easy for you to do. But if you are not interested in that, we'll also come to trading bots a little bit today. So that's about alphas. We like quiz 5 was already thing is released. It's done. Quiz 6 will be released soon. It would be mostly based on the previous lecture only. So two quizzes on that same lecture because we covered 2 notebooks. One was feature engineering and second was pairs trading. I think the quiz that we already released was the more based on pairs trading arbitrage things. So uh, that's there. Then yeah, both positions are open. Interviews we'll do next week. This week is too busy for myself. Then yeah, I mean, yeah, I think the other part I already covered. So let's go to the next thing. So given that we have this WorldCon good ranking, Cont Connect also is interested. I spoke to them just recently, and they are inviting us to Quant League. So how is this little different? It is mostly like having several benefits. Mainly, I see one which is code can be written in Python or C sharp. So people who are facing problems like, oh, I don't know fast expressions, then like Python or C sharp, you can actually code in give like the syntax of Python or C sharp to that platform. Second, it's not public to everyone. Not everyone can participate. It's only through specific student orgs they assign at every university. So just one at every university, what they chooses, and they like uh, making TQT do it. So if you are interested, just like reach out to me that okay, like you want to do this competition. They want like actual active users, and why they want active people only is that the code is actually visible, everything is open. So whatever contribution you make, it's on your name, it's on the code is public, so employers can see it. Their task mainly is to make this competition more employable. So like employers can see what skills you have, how the code is implemented by yourself, and what's the like overall profit making strategy. So very useful. I believe that's a good competition to take part in. Um, and then they also have prizes similar to what we have worked on. This is not like that big of a competition as I know, but it's pretty interesting the way I saw it. Um, so yeah, we will probably host session by them also pretty soon, but not yet. I would probably plan it later on. Quarterly, so this competition is quarterly, so it would run every quarter. And we will be only people who do it. So if you want to participate now, very welcome to do it now, because this might be like a good point to start. Later on, it might get too competitive, like later quarters, because they're gonna reach out to many such student orgs. Currently, there are just like very few universities, so very good visibility on what work you have done. So do that, but it's not part of the course yet. I'm not taking this as part of course pretty late. So, but that runs till 30th June. So even if you are like busy with like till finance week, you still have like the 2 weeks left to like actually actively participate. Yeah, so that was Con Connect. And then this was a great timing by them to reach out also, because now we are going to learn about trading bots, which we also plan to do on Con Connect. So let's go on that. Before that, yeah, okay, let's just see this slide first. So trading bots, bot in general, I think everyone is aware, bot is something like where you personally are not manually trying to do something. Bot is like an automated system doing something for you as planned by your strategy. So what's the trading bot we are trying to make? It's very simple and interesting, is that a breakout strategy which dynamically change look back length. So we generally, whenever we have a trading strategy, we have a look back of like 30 days, 20 days, 10 days, so on. So how do I like keep on changing based on the stock price change? So I want to change my look back period, and I want to implement a stop loss. So like if you are uh, facing a lot of loss in that specific stock, then you probably need to sell. So stop loss is a like very common term to mitigate that. Like whenever some stock reaches its uh, stop loss price, it's automated that you will sell it. So stop loss can even be just done using like your normal stock app. But like how to do it in code is what we are trying to see. So there are two main things in the code I will show you. Is first thing, initial stop risk. So initially we set this stop loss at 98% of the value. So if the stock is decreasing just by 2%, you're gonna sell it. We probably don't want that, but that's like just the initial setup. Then whenever we move in time, we try to update this using trailing stop risk. So like the way we'll be using is trailing stop risk. Again, it will be a number between 0 and 1. So if my trailing stop risk is between it's let's say 0.9 as I am taking, then that means a 10% decrease in stock price would make a sell order happen, right? So from 98 to 90 we are doing. Um, how this is updated? So what happens is this trailing stop price is updated based on the stock prices. So if uh, the highest recorded price of a stock increases, we probably do want to increase the stop loss also, right? So let's say your stock is consistently increasing. That's why you might have invested, right? You do think that will increase. So if it's increasing continuously, it's making its highest recorded price of like, let's say past 30 days, then you want to update its stop loss also. So you are increasing the stop loss as the highest touch the price is increasing. If it does not, like let's say today it was 100, it touched 105 tomorrow, 110 tomorrow, you do updated it, this stop loss price. But then it started decreasing to like, let's say 105. And then it's like again increasing to 106, 7, 8, 9. So that increase again doesn't matter because it already touched 110 just recently. So that won't change the stop loss, uh, the trailing stop loss, but the initial 110 jump would change it. So now let's see how like to do this in code. I'll probably like split share. Mhm. I should have probably Okay. Yeah, I should have probably attached the link. So this is based on like a video made by someone else. But there is more to it than like just given in that video. So I'm trying to explain how that works. So this is like the ConConnect platform. On that, if you okay, let me show you how to go through that. So if you go to ConConnect and like terminal. So first you have to register, but let's say you have registered. You click on create new algorithm and just use default template. And then you can copy the code that I will be sharing, or the original video has that link. So you can just clone that code. But let's see like how it actually works. So usually you just see something like this. This class name can be anything. So this is like a Python class to implement. Oh, okay, so yeah, it's like a class. They named it randomly currently, but what you can do is you can name it as per yourself. QC algorithm is just like a Cont Connect algorithm. So it's telling that, okay, this is algorithm at Cont Connect. And you can do all the imports using this from algorithm imports, import start. So that's the only line that I had to add in that code to do anything. So let's go back to that original code. So how this will work is first I created a class. It's a simple breakout example. So the breakout strategy we are doing. First function is initialization. So what we are setting are different variables that we will be using during the strategy. First is set cash. So you are setting like how much money virtually you have. So it's about 100K right now. Start date and end date are where your testing happens. So when you have implemented a strategy and you want to test how it works, that's the date you'll be using. Then add an asset. So you are adding a symbol spy. So we are doing it on the spy index. And resolution we are using is daily. So you'll be using the daily stock price data, mostly closing price. And then dot symbol is like converting that spy to the ticker symbol. So that is the symbol variable we have. Then we have a look back. So um, look back is set at 20 initially. And we will be changing the look back period based on this, right? Based on um, how the volatility changes, that will be changing. So I'll go on to next slide first to see. Okay, yeah. So how does that change? So based on the volatility of your stock, you'll be changing this look back length. We're just setting initially 20, and the highest and lowest I want to go is 30 and 10. So I don't want to go very low, and I also don't want to go higher than 30. So if at all, based on conditions, it touches above 30 mark, we'll just cap it to 30. If it touches below 10 mark, we'll cap it to 10. So now let's see like how we are changing the look back trend. So you have a breakout strategy where first we calculate today's volatility. So standard deviation of the closing prices for last 30 days, excluding the current day. So you're not using the this current day. And yesterday's one would be the one prior to the current day. So like a day of a difference between these two. I believe, okay, I think excluding the current day and prior to the current day. So like a one day before than that. So there is just one day of a difference between these two volatility, and what you do is calculate the delta. As we have calculated in other terms before, you calculate the delta, which is rate of change in volatility. So what you do is subtract these two and divide by today's volatility. So that gives you the delta. Now, what you do is the look back period is updated as by multiplying 1 plus delta. So let's say let's take an example. Um, so let's say your initial was 20 as in the code, and your today's like last 30 days volatility is 1.5. And then yesterday's one is 1.2, so it decreased, right? Now that it is decreased, we want to calculate the rate of change, that is the difference between these two, divide by the today's volatility, that's 1.5, and you get 0.2. So that's the rate of change. And now your new look back period is just 20 multiplied by 1 plus 0.2. So you get 24. Now what does this 24 mean is you will just update this in the code later on, your look back period, and now the code will look back 24 days instead of 20. So decreased volatility, or I would say, yeah, increased volatility increase the look back period. So if it's more volatile, we want to look back more so that we get a better sense of what's happening. So that's one part. So in the trading, like in this bot, we are doing two things. First is updating the look back. Second is the stop loss. So the stop loss idea was as this one. So let's see example of that also, and then we can go to code. So the example for that is, let's say your bot, when it initializes, enters the position at $100, and your initial stop loss, as I said, was 98%. So you are setting initial stop loss is 9.98, and your trailing is set to be 0.9. So your initial was $98 stop loss. If the price of the stock rose to 110, you want to increase the stop loss as well, right? So what you have to do is calculate how much is the increased rate. So it increased by $10, right? $10 multiplied by or I would say just, yeah, directly 110 into 90% of it. So the trailing stop rate is 0.9 into 110 gives you 99. So now your new stop loss is 99 instead of 98. Why? Because your highest price increased. Does that make sense? Devan? Any doubt? So how this will, how the update will happen here, we were just setting initially. Now let's go to the next part of code. So this is scheduling a function of after every 20 minutes, you'll make this update. So it's not something that you need to care about. Like, let's go on next function. It's saying just on data, so that helps you plot it. So when I will run this code, it will plot like a chart of how the closing prices, how the stop loss and everything varies. So that just helps you on plotting. Now let's go on every market opens. So whenever the market opens, dynamically determine the look back length. So first we are doing sense.history. So that gives you the past data of uh, the data you want. So I will probably have a close. Yeah. So a close means like a closing price of it. So you'll get past 31 days of closing prices. So that's just the syntax of it to get the closing price. Sell dot history, the symbol what we just assigned was SPY, right? So the SPY data of 31 days, resolution is daily. So daily closing prices of 31 days. Then today's volatility is given by the closing prices of last index 1 to 31, and then that NP dot standard deviation is why we actually imported this. Like we imported NumPy in the start. That was because we wanted to calculate volatility, which is standard deviation in the closing prices. So we calculated that. Next, we have yesterday's volatility. So the one previous to it. So we started index 0, go to 30. So that gives the two volatility we want, and then we calculate the delta. So I mean, just if we want to refer. So delta gives you the uh, difference between these two divided by the today's volatility. And then you update the look back according to the formula, just 1 plus delta volume into self look back. Now, coming back on the part where we said we don't want to go above a certain volatility or below. So then, or the look back. So if the look back actually after calculating gets above the ceiling, we just reassign it to the ceiling. So we cap it to 30. And if it goes below 10, we still cap it to 10. So that's just a safety measure to not let like very high jump in prices change our look backs very much. So we'll stay in the range between 10 to 30. Now, daily highs. So as we calculated closing prices, that helped us for look backs. Now we want the highest prices so that we can change our stop loss, right? So for stop loss, we are using the highest price touched. So this was the first like highest price of last look back period. So this is where your actual look back is used, right? So you want to see in past 20 days how much the highest price changed. If it already increased by that 100 to 110 amount, it will look back for 24 days. So that's the dynamics. Once the look back changes, your stop loss also is affected by it. So now again, the resolution is daily, and now we are seeing the highest prices. So next, what we want to do if we are implementing stop loss, the stop loss part comes later. First, like we need to think about when we are actually buying the stock itself. So when we buy is it's called a breakout. So breakout happens when your closing price is greater than equal to the highest price touched in the past, right? So you looked back, you saw that okay, this was the highest price touched in the past. If it touched it, you're gonna enter. So you entered the position based on this condition, and you set the breakout level to this new highest touched stop price. Next, we create this trailing stop loss based on the new prices. So if now you have entered the stock, like you have bought it, now you want to implement stop loss. So for all the transactions that do not have a stop loss executed, they are like an open order without a stop loss, right? So if uh, the self dot transactions get open orders gives you all the open orders, so all the ones which you have bought, if they do not exist, or that means like it's a not a zero value, that means it's false, then you should implement a stop loss, right? So then you go on to next line, you say stop market ticket. So that gives you the, okay, this I think should expand little so that we can see. Um, Oh, that was the other one. Yeah. Yeah, you can only run like one at a time. So you have to stop the other one. Hmm. Wait. Oh, that was other algorithm I did. Hmm. Hmm. Testing why it doesn't load that. Loads in here. Okay, I'm just gonna have this open. So now, continuing on that, so once you figure out, okay, what are the open orders which do not have stop loss, you will multiply your initial stop price, which was 0.98, to the breakout level. So the breakout level we have from the maximum high price before, and you will assign this into a waiver stock market ticket. These two are just to know which symbol you are assigning. So we are using SPY here, and then the quantity. So the amount of stocks you bought, like let's say 100. So that symbol, and then the actual variable we want is this initial stop risk into the breakout level. So that's uh, the value you are assigning to this variable. Now, let's see if the asset price is higher than the highest price before. So this is where your trading happens, right? Like you are uh, trying to see if your closing price currently is higher than the highest price before. And then if that happens, you have to set a new high to the highest price and update the stock price. So update fields is like instance you are creating so that you can update. You call sell security and update it. So update the stock price to this value. Note that now I'm using trading stop risk. Initially, I used initial stop risk when I just assigned it. So the update happens here, uh, and the trailing stop risk, as we said, we used zero point 0.9, and we calculated like through the example you can see that we calculated as zero point 0.9 into 110. So if the current price is 110, that value is set to 99, the updated stop price. Now, just to see like what's the new stop price, you can do this. So yeah, that's like pretty much most of the code. The last is the plot function that we created here. Uh, the plot function, we assigned initially data chart, the symbol and the closing price. So now we'll plot it. I don't think this would run because this one is running. So probably just stop this one. Mm. Okay, yeah, I mean, I already kind of ran it before. So after you run that main.py file, you will see how much your holdings are, how much you make profit out of this strategy. Like you're updating the highest price and you're executing stop loss. So you are being greedy about making the profit through the volatility look back change, and you are also minimizing the risk based on your stop loss. So pretty good simple strategy to make a profit, and you can see like it made about like 16% of a profit uh, based on this. Is it understood? Any confusion like the code part? I can share the code part. Sorry that I didn't had a code for that, like QR code. But you can just search, or let me. Okay, that's fine. I'll share the code when I post this. So yeah, this is the result we get based on this. So these were the two scenarios, how we change the look back period and how we change the breakout level stop loss. Okay. So next is just a general overview, like as we were on that syllabus, we mentioned we wanted to also learn about just in general about trading systems. Like we are looking at a very high level picture of like, oh, you just call like self dot high price, self dot closing price. Even in your word count alpha, you just call like, oh, past 100 years of data, or like, I mean, 100 days of data, TS delta, all those variables works so smoothly. But there is a lot going in behind on like how this systems which trading companies have interact with the actual stock exchanges. So this is like a diagram from Federal Bank of Chicago, and the trading system built around this currently mainly has two parts. First, this is your server. So the, let's say, Optiver has the server at their company, and this is the stock exchange. So the exchange who is actually providing the data is over here, and they are interacting with the server situated in Optiver. Why does Optiver want a specific server? Like, why cannot they also just use a random app which displays the data? So the primary reason is you want to be quicker than the market. You want the data as fast as possible and execute trades as fast as possible, right? It's matter of milliseconds that people make profits in. That is why most of like opportunities which are like straightforward profit, also called like arbitrage, they are not existent because of these companies. They execute trades very fast, they analyze the data, read the data very fast. So what these companies do, they buy kind of a subscription to the index they want the data from. So let's say NASDAQ. NASDAQ gives them a subscription of this data. So they will send the data to the Optiver server in a different format than we usually see. So we just see like, oh, this was open price, close price. That's not how they send it because that takes more time. We want to send the information in a very low level, uh, mostly binary or like byte level of information, and then they can read it, pass through it. So let's go over how that happens. So the market data is sent to the trading server, and that like is crucial for making informed trading decisions. So um, we in the current figure, like don't get overrun by other parts. Center two parts are main. So you can see these arrows, which are saying that, okay, this information is flowing this way or the other way, right? So first is market data that obviously flows from the exchange to the trading server. Second is heartbeat. So heartbeat is just like a check. When you want to check, oh, like, is this connection active? Like, am I receiving the most updated data continuously? So it's just like a signal between both exchange server and the trading system to see, oh, is the connection established? So it's just a thing to check. Second, or the most important part is the order flow. So order flow is first order entry and the second order update. So order entry is when a trader, the optiver, places an order, buy or sell to the trading server. So this information goes from trading server to the exchange. Exchange we are taking here NASDAQ, can be anyone. So that information flows from server to the exchange. And order updates is when the exchange informs Optiva that, oh, your order has been executed or cancelled or like partially failed. All those updates are given by exchange to the Optiva, right? So that is information flowing from exchange to the trading server. So you can go over like other plots also. There is like broker dealer part, trading firms, clearing house, but most data that flows at very high frequencies between these two, and then other connections help like translate the data to, let's say, us. So we receive after this workflow is done. So first data type that NASDAQ uses is called a QBBO. Its full form is best bid and offer. So how that looks like is something like this. So you can see like bunch of bytes written in hexadecimal form, octagon form. There are different formats here. So it's like a tape. Like I'm sending you like a videography tape, if you remember, like how it used to be in cameras. That's like a tape. It's written with these messages every time a trading session happens. So it gets printed out on it and it's getting sent to the trading system. Now it's like digital, but I'm just giving example so that you understand that's like a complete line of script being printed upon messages. So how to read them is like a specific format. NASDAQ has their documentation on this. Um, but the key ideas from the documentation are uh, like the indices. So what message is being read from what part of the index is what matters. So firstly, the timestamp is there. So when the activity happened, whatever it happens, what is the timestamp of it? Second is the stock status. So there can be, let's say here you see MSFT, you can probably recognize that's the Microsoft stock happening. So the activity is happening in Microsoft. Then is the bid price. So at index like 18 to 4. So that's like a 4 length of bid, and then that's the bid price. Then you have bid size, ask price, ask size. So that whole line of message that I have written above is divided into like these parts. Why did we start at 3 is like because these first you can see they are consistently just x00 x00 and there is just one character here. So that part is not useful to see uh, the bid price and ask price part. That just to recognize what's happening. So Q means start of market hours. Or actually, oh sorry, yeah, Q means start of market hours, but S is the start of system hours. So when you see a S code, you will probably just see like a half of what I have in the second one, right? Because it's just starting, nothing has happened yet. The market is not open, no orders placed. So just the S code gives the timestamp of when the market or the system started running. Okay. Then the Q means like, oh, some market activity is happening, and that's the start of it. So the start of the activity and then what happened is through this other message part. And then there are others also. So when the market ended, that would be given by M. Then your end of system happens through E. So after E happens, uh, market is done, no transaction. So this will be like probably last line of code. This is almost every time the first line of message, right? And everything between is mostly Q, M or C. I mean, M is also just once, but Q and C mostly would be there. So let's see example of how that message which I just wrote is read. So if you try to convert that through documentation, that means the start of system hours at that time. So that first message just gave you the timestamp of the when the market started, right? So or the system started. So that's just timestamp conversion. That is April 2022, 2019 at 4 a.m. and how much milliseconds. So that other part is just milliseconds, no like minutes, hours, everything. There can be that also, but that was how it was written. Second was, you can see Microsoft right here. So that was a transaction that happened on Microsoft. Someone bid a price of 80 for 100 stocks. There was no like ask price or ask size at that time. And that order was, or that information was given to the Optiver at 16919 milliseconds after that 4 a.m. Okay, so you can see like how precise they want to be for making these information available. They are giving it in milliseconds. And then the next was Apple. The transaction happened just like 300 milliseconds after it. So the bit price and bit size you can see. So if there is no ask price, ask size, that means like no asking orders have yet been placed. And which is why you probably see like at the end of this, you see all the zeros, right? That means there is no ask price, no ask stock like size of it. So no size or no price for the asking part. But here you see some values, right? However they are written, but they do have some values. So that's the bidding part. So bidding part, then the ask part. So those were two examples. Level two is the ITCH one. So this is a newer version. This is not so QBBO that I told you is not actually the one given to the trading bigger companies like Optiver. They use the level two one. And it is little complicated to understand, which is why I took QBBO as example. But ITCH is the one actually taken by these companies, and how it also looks something like this, more little complicated, but you do want something more, right? Like this is just bid prices or ask prices, but trading companies want the full order book. So like what trades happened, what orders were placed but cancelled later, what modifications were made, and like in-depth analysis. So those kind of strategies, if they want to implement using the other information, then they want to use the level two data. So I think QBBO used to be like a standard thing earlier. Now it's like almost not there much. Mostly people use the ITCH, like the companies. We as like free users mostly can access the QBBO and read it. You just have to parse them. The only thing is like here, as I said, this like indexing doesn't directly give you because it's in bytes, right? So you have to convert it into string, and also if something is integer, you have to convert it into integer. So the conversion is pretty simple, but it's just little time taking on our side, but the systems can perform it very fast. So in order of milliseconds, you get the data faster than like public. So yeah, that was mostly this. I also wanted to give, yeah. So you can scan this QR code. Um, this is mostly like how optimization happens. So you already like saw how the trading systems are there, but how best we can optimize them to read this information or any kind of order flows that we want to make, how to like make them fast. So the key idea is they want low latency, right? So latency means like how much data, like let's say you have a pipe, how much data you can pass in through that pipe, right? So it's determined by the lowest radius you have in it. So that's like your bottleneck, right? So higher your bottleneck, the more is your latency, the higher like amount of transactions you can do, higher amount of data you can retrieve or send. So for trading companies, latency is very important. And latency optimization is what is talked about in these two links that I have shared. What mostly is written, let's like actually go to this link. So one key idea in the optimization part is FPGAs. What are FPGAs? They are just programmable gate array. So it's like a chip that can be programmed to suit your needs. So every company takes that chip, modifies it by the requirements they have. So if you have a FPGA, you can probably process your trading systems more faster, more latency. So FPGA is mostly like a solution to increasing your latency. And now you can like read about it. I'll give you like 2-3 minutes first, just so that people can read what's written here. It's a very like simplistic way in which it is written here. In the other link, that's a video where like Optiver trader person is explaining how they use it. That's more in depth, so I would suggest reading it here. Okay. I also realized that I didn't go over that example. Okay, how many people are here like who didn't have a alpha working yet? Like they're trying to, okay, some hands. So I'll just show you that email that I received. And okay, maybe I should unplug and deplug. Yeah, okay. So like that kind of emails you might receive, and you can just see like how clearly they have said like what to use this, or I believe there was a previous one. This was Yeah, this is probably, yeah, okay, I think that also worked. But this anyway says like you can use higher sales. There was one where like literally nothing to do. Yeah, here. So I think this was given, and they were just saying could observing over a shorter period improve accuracy, something like that. So uh, you can try like a quarter one, and they have also given you simulation settings. You can just try that. I mean, it works well through these kind of examples, or when you like go on their portal and just click, let's say if you click on the example button, they will give you an example, and that can help you like just get a good alpha example with all like this given the hypothesis. So like what's the strategy they are using. So here again you can see this specific variable is very like useful. I've seen it several times in their clues or anywhere. So you can just like keep clicking on example if you don't like and see what works. So this was one of the ones they just shared in their email. So try to just like submit something. It kind of helps you to learn also and also get you some points. um this was one. How many people, if any, are like interested in the Connect one, like the trading bot? Anyone? Okay. Kind of. So yeah, I will release like more details on how to implement. I mean, that already is there. It's like an implemented strategy, but we can modify it if we want to like make it as like our project. So we can probably think about more strategies on how to execute. Like, let's say they executed stop loss, we can do um a higher limit on how when to sell. So those things can be done. Um, I believe I didn't cover one last part in the features engineering or the arbitrage notebook, but I mean we already released this quiz on based on this. One important part I wanted to highlight was the beta. So this beta is very important. This wasn't there in the original code that I referred to, which is in the link below. So the beta calculation is that slope between the two stocks that you are calculating. So the appropriate slope where this spread between two stocks remains consistent, right? So it is increasing by y equals mx plus c, the spread. So you want to know what the value of this slope is. That is the beta. So let's say your two stocks can be something like this and this. So here you can just say, oh, like this spread is almost constant. So your slope is here, m is 1. But in the cases where this is like increasing this way, and this is like little slow. So there's like a factor by which this spread is increasing. So if you are plotting the spread, it is increasing by y equals mx plus c. And that factor is what we are calculating. So the two here in Google and Home Depot example was that slope. And it's not there in original code. The way to calculate it is here. So that's where your add filler test is helpful. You see where your two series are becoming stationary, and the best scaling factor is the beta. So I named best scaling factor here, but that's the beta. So the beta value you calculate here is actually used later. So since I printed out here, it's 2, and then I use it later. You can like also assign it every time you execute the code so that you don't have to like reassign everything. Um, so that was, I think, an important part. I felt like in quiz it should be helpful. You can look up your add filler test. I think I shared a link. I'll share in Piazza also. I think I didn't share in Piazza. So that was about stationarity. One last thing in this uh, was after the Verizon and T-Mobile example, uh, which was Um, yeah, yeah. Yeah, the variations part. So after like we saw this RSI and resistance level plot. There's one more part where we want to do target labeling. So the code below is calculating the percentage change in the closing price and shifts uh, it by 1 day. So that represents our target. So we want to label the targets based on percentage shift. So this PCT change is the percent change for the 1 day. If you want to do for n days of variation, you can just assign that in a different value. And you then have this target variable column where you can have values starting from index 2, right? Because we are calculating the percentage change from this point. So it will take the percentage between these two first points. So this is where like your target variable is created, and you can see the variation in it. Um, Next is like, how do you classify them? So you can find the percentile on it. So 33rd percentile and 67th percentile is the split uh, to use the data in like two different sets. So once we separate it and then we calculate the percentile, uh, dummy variable you can ignore for now. The dummy variable is just you assigning 1 or -1 based on in which group it is. So centile 6 or 67 or 33. Okay, 1 second. Yeah. After the time. Okay, so yeah, the food people call for the delivery every time. So the dummy variable here, the column is the 1 and -1 represents if it is in 67 percentile, then it's a 1. And if it is if it is less than the 33 percentile, then it's a -1. So that just labels how and when to make that trade happen based on 1 and -1. So we were doing this before also. If you see these green and red dots, we assign 1 or -1 based on when to sell, right? So the same thing here. And you can refer to this book, which I'm referring to. I modified the code based on what we wanted to do, like calculating beta and all. But this is the original code in the book, which is useful. Okay. So I think I'll just leave on the concurrent trading bot thing if anyone like has a doubt in this part. Oh, yeah, one thing in this is also a research Python file. Um, can I don't think I can see it. Okay, so these were like trades that happened through uh, running this code, but you can also see the graph. So I want to look up the graph. Hmm, not even moving. Oops. Hmm. Yeah, okay, I got the link. So is everyone here in the Discord? I just shared the link there. So okay. So that was the trading bot one where you can find the link to this code. So if you go on the description, you'll find the code to this, and then you just have to register at Connect once for free, and then you can clone it. So your algorithm is found over here. So let me create the QR. Hmm. Okay. Yeah, I think if you want to scan, like just take a picture of that QR code so that you can like go to that repo where Connect algorithm is written. Um, yeah. Okay. Think we are almost done with that. Um, so um, yeah, this was the graph I was trying to give a sense of. So like when you plot it, you can see how your stop loss is changing, this purple line. So based on the highest price curve, this also increases or decreases, but not a very high fluctuation because we limited it by the upper and lower look back length. So if it is 10 or 30, then that also did not fluctuate much. So this is like a community here, a whole forum on discussion of how this strategy looks like, how like changes were made in this. So you can like see uh, the strategy similar to this in the portal.